Here's the way that I would strategize. Now, these problems can be solved in a numerous amount of ways. So I'm going to show you one way. And first thing I would do is just to skim over the things that I have to solve for. So I have to solve for a length. I have to solve for the angles as well. Something that comes to mind immediately is the Pythagorean theorem, because I know two sides, and if I do a squared plus b squared equal to c squared, I would easily be able to find km. However, that might be a little bit too much work, and if I can avoid doing more work, I'll try to do it. So I'm just going to try to do the angles first and then see if this is still appealing. So for measurement of angle k, I can see that I have two lengths, which means I can apply a trig inverse function to solve for k. So let me write that down. Now, specifically, let me label k as theta. So if I use theta as my angle of reference, I know that this side is going to be my opposite side. And then the length that's across 90 degrees, that's going to be the hypotenuse. So then this part is going to be my hypotenuse. So let me write SOHCAHTOA. And here, in this scenario, in order to find this angle theta, I'm going to be using my opposite and my hypotenuse. Opposite and hypotenuse screams for sine of theta. So here, I can even sketch this out a little bit more precisely. I'm going to have to use sine inverse of theta. Okay, so that's just my sketch, my strategy. So let's strategize how to find measurement of angle L. Now notice, once I find the measurement of angle K, I'm going to have two angles, two known angles. I'm going to have this 90 degree angle, and I'm going to have this angle K, or angle theta. So to find angle L, I'm going to use the sum angle theorem. Here, for finding the measurement of angle L, I'm going to use the sum angle theorem, aka the interior angles in a triangle sum to 180 degrees. So here, once I find angle K, I'm going to get 180, and I'm going to subtract angle K and subtract angle M, which is 90 degrees. To find the measurement of angle L, I'm going to use the sum angle theorem, aka the interior angles in a triangle sum to 180. So once I accomplish solving for angle K, or theta, I'm going to get 180, and I'm going to subtract angle K and subtract angle M, and angle M is 90 degrees. That's going to give me angle L. And let's, for simplicity here, let's call angle L, I'm going to call it beta. So now that I have angle L and angle K, notice that by that point I'm going to know the value of each of these angles. So if I use angle beta as my reference angle, I can see that this side is going to become my opposite side in reference to beta. The hypotenuse is still going to be 9.6 because that's always across 90 degrees. The 8.4 is going to be adjacent to beta. However, here, instead of doing Pythagorean theorem, something I could do is apply trigonometry. I can apply the opposite side over the hypotenuse, and that's going to give me the value of km. In order to find the length lm, I can apply sine of angle L, which I've conveniently labeled as beta. So that could be an alternative to doing Pythagorean theorem. But again, this is just one solution. There are many ways to do this. So let's go ahead and show you this solution. So here, again, I have to solve for all of these missing pieces. So I'm going to begin with k. So I'm going to label k as theta. I like doing trig with Greek letters. If you want, if you're comfortable, you could just leave it as k. So here, I know that the side across of theta is going to be my opposite side. And the side across 90 degrees is going to be the hypotenuse. So these labels are in reference to theta. So since I have the opposite and the hypotenuse, this is going to tell me to use sine. So sine of theta is going to be the opposite, which is 8.4, all over the hypotenuse, which is 9.6. Now, since I'm trying to solve for sine of theta, or actually, I should say, since I'm trying to isolate theta, I need to get rid of sine. I can do that by applying sine inverse to both sides. So I'm going to compose the left hand side, and I'm going to compose the right hand side. So here I have sine theta, and here I have 8.4 over 9.6. The inverse functions cancel out. We just get 1 times theta, and sine inverse of 8.4 over 9.6. So 1 times theta is theta, and this is going to approximate to the sine inverse of 8.4 over 9.6, which I'm getting to be approximately 61 degrees. And here we're rounding. So we're rounding to the nearest degree, and we're going to round to the nearest tenth for the length. So here, let's box this. Approximately 61 degrees. Now, if you have, for the approximations, if you're off by just a little bit, that's fine. As long as you're not exaggerately off, such as if I would have gotten 43 here, then yeah, that's not good. Or if I would have, even if I would have gotten 58, that's still far. You need something close to 61. So here, now that I found theta, my next plan is to find angle L. So I'm going to call this angle beta just for fun of it. You can leave it as angle L if you like. So here I know that theta plus angle M plus beta, they have to give me 180 degrees. This is the sum angle theorem. Sum angle theorem, which says that all of the interior angles in the triangle, they sum up to 180 degrees. So now I'm going to split this equation here. And angle theta, I can replace it because we just solved for that. So theta is equal to 61 degrees. So I'm going to substitute theta for 61. Angle M, that's the 90 degree angle. So we can substitute angle M for 90 degrees. And now we have beta, which is the unknown. On the left hand side, I'm going to simplify, combining like terms. Here's 61 plus 90 degrees. That's going to give me 151 degrees. And we're going to add that plus beta. To isolate beta, now I have to get rid of this 151. This is a positive 151. So I'm going to do the inverse and subtract by 151 degrees. And whatever I do on the left hand side, I'm going to have to do it on the right hand side. So on the right hand side, I can subtract by 151 degrees as well. And here, 151 minus 151, that's 0. So we get 0 plus beta. And then 180 minus 151, that's 29 degrees. So 0 plus beta is beta. So we get that beta is equal to 29 degrees. Let's go ahead and jot that down. So here beta is equal to 29 degrees. And theta was equal to 61 degrees. All that's needed now is this length. And again, we could go with Pythagorean theorem, doing a squared plus b squared equals c squared. And that would definitely give me km. However, since I know all of the angles, something that's more appealing, at least to me, is doing trigonometry here. And here's how I'm going to apply it. I could technically use theta as well, but I'm going to use beta instead. So now I'm going to label the triangle in terms of beta. So if I choose beta to be my reference angle, then length km is going to be my opposite side. Now the 9.6 is still going to be my hypotenuse because that's always across a 90 degree angle. 8.4 would be the adjacent side in the reference to beta. So since I have the opposite side, that's what I want to figure out. I'm going to call it y, just variable y for now. And I'm going to use the hypotenuse. Opposite over hypotenuse, that's sine. So I'm going to take the sine of 29 degrees. The sine of 29 degrees is going to equal y over 9.6. So let's go ahead and do that. So sine of 29 degrees is going to equal the opposite over my hypotenuse, 9.6. And now here, this is better, or at least in my point of view, it's much easier to manage. Here I'm going to divide sine of 29 by 1. I have a proportion, so I can cross multiply. I'm going to do 1 times y. That's going to give me y. That's going to equal 9.6 times sine 29. So 9.6 sine of 29 degrees. And now I can input that in the calculator because my variable has been isolated. And here, this I can calculate. And I'm getting y to be approximately equal to 4.7. And that is the length of km. Km is, I labeled it y. And this is going to be 4.7. Well, approximately. But you get the picture. So here, I've just succeeded in solving for the missing angles and the missing side. Again, just to reiterate, you could have used Pythagorean theorem to do this part. You could have also used theta as well. You could have used the cosine of theta because this side is the adjacent in reference to theta. So you could have done adjacent over hypotenuse of 61 degrees. That would have given you the same thing. But it's your turn to try these out. So go ahead and complete the assignment, and I'll see you next time.